Hi, I'm Rich with Inside HPC. We're here at ISC'12 in Hamburg. I'm here at the Micron booth. Let's start at the beginning. Who is Micron and what do you guys make?
Well, we're not a supercomputer company, but we're a memory company, and we make memory that goes in supercomputers in a variety of forms, both DRAM and NAND Flash. And we also make NOR Flash, but that's a little bit less interesting to this audience.
Okay, yeah, so memory is big in HPC, so what's going on in memory technology in this space?
Oh, there's a lot happening in memory technology. You know, first around DRAM, we've got DDR3, it's going faster today. It's in all of the Sandy Bridge and Ivy Bridge systems that are coming into the HPC space. It's in other systems as well. If you take a look at the Blue Gene Q boards, they're loaded up with DDR3. DDR4 is the next thing that's coming in this space, and that's hot. Then there's the hybrid memory cube, HMC, and that's a radically new technology that this audience is extremely excited to hear about.
Okay, so that's being developed by a consortium of companies, is it not?
HMC is a consortium, but Micron did introduce the technology about 18 months ago, and it's just really resonating with this audience, and the consortium is pulled behind it to develop those second and third sources that make these types of things a success.
So what are going to be the advantages of this technology?
Oh, that's big. It's performance for this audience, and it's power, which this audience is also interested in. And here we are delivering a technology that at one time can deliver about 10x the performance and cut the power dramatically. This sort of revolution has really never happened in the memory industry. And it's unheard of. So a lot of excitement around getting this technology in.
That's going to be really well received when
big.
it comes to market. Okay, so what do we got going here? You guys also do, as you mentioned, what kinds of flash do you base your device on?
Well, we base it on Micron Flash, of course.
Oh, certainly, but
Flash.
is it Nandy or what do you got? So,
okay,
yeah.
So these are NAND Flash devices, and there's two types. We have an enterprise drive here based on enterprise MLC, so the multi-level cell NAND. This is the enterprise SLC, heavier duty applications, more write-intensive applications, faster performance out of this drive here. But if you really want the ultimate in performance, right here is the PCIe-based system, and based on 8x PCIe running at full speed. Loads of SLC NAND Flash here. This is the ultimate storage solution. Again, getting a lot of excitement around all of these technologies, but in particular this one here at this conference.
Okay. So, you know, I sit in on a lot of the Exascale meetings, right? And they're talking about how an Exascale system, half the cost might be memory, right? Now, I know there's not much you can do about that, but
no,
they
we
also
like that.
you like so that's good for you, but at the same time, a lot of power requirement, right? That they're not going to be able to meet their goals. So are they beating up on you guys to get on a track that'll serve that need 5-6 years down the road?
Well, keep in mind, everyone has to cooperate to get to the Exascale power targets. We're going to keep this machine under the 20 megawatts, which is a lot of money. That's a lot of money to run it. It's a lot of power, a lot of cooling and all that. We're going to keep machines under 20 megawatts. We've got to have cooperation from a lot of different team players here. And we're doing our part. And the hybrid memory cube, the HMC, that is certainly a real big part of how we're going to get the power down on this and deliver on the Exascale promise.
Okay, so I just want to ask you a little bit about the market. You know, core counts continue to rise.
Yep.
We've seen the #1 system with 1.5 million cores. As you raise that, you have more need for memory, right? Do you see that continuing?
Yeah, it absolutely will continue. There are some people that say for every flop of performance you've got, you should have a byte of memory. So, you know, we're talking about exascale, exaflop type machines. There should be an exabyte of memory. I don't know if we're going to see quite that much memory in those systems, but it sure would be great. And it does enable really performance efficient machines when you've got enough memory. So yeah, we're being pushed on memory density as well. We have load reduced DIMMs that allow higher density in these types of systems. And you know, that's just a part of the solution that we're offering for these high-end, big iron machines.
All right. Well, hey, thanks for sharing that with us today.
Yeah, very glad to. Thank you.
Okay. I'm Rich with Inside HPC in Hamburg. We'll see you next time.